So we will turn it over to our own Isaac Evans, who is going to give us a little information about heat pumps.
Perfect. So I'll go, I know we got about 5 minutes here. So I'll go through this a little bit more quickly. This just came up in our leadership meeting talking about just things happening around air source heat pumps. There's a lot of buzz going around them right now. And just general misconceptions about them. What are they? What role do they play in the future? Or what role could they play? And just some of the different terms that surround them. Because I'll get to why later. But so first of all, what is an air source heat pump? I'm not going to go into any of the mechanicals of how heat pumps work or anything like that. I don't understand exactly how they work. You can probably ask Bill Middlecamp if anyone's really interested on the engineering side of things. But essentially, it's electricity-based heating, ventilation, and air conditioning system. It's ultra efficient. You get systems that are great, have a efficiency greater than 300%. And if you're getting a high-end furnace right now, that furnace's efficiency is going to be about 96%. So you can just see how much more efficient a heat pump would be. The biggest misconception I see in my work is people not realizing it heats and cools. So it can work to supplement some of your heating load and replace an air conditioning system. That's just in the name, it's called a heat pump. So people don't always necessarily think that it would cool at the same time. And as you can see by this generic picture I stole from the DOE today, it does kind of look like standard residential AC or equipment that you would normally see outside of a home. There's a lot of terms that go around with an air source heat pump. You hear cold climate air source heat pump, a coefficient of performance, ductless versus ducted, single stage versus two stage, dual fuel systems, seasonal energy efficiency ratios. And this can be really confusing for people who are trying to either replace an existing AC or heating system or add, some cooling load to their home. So I get a lot of questions about, okay, what should I be looking for? What kind of specs should I be looking at for whatever kind of heat pump I'm looking for? So the first big difference, ductless versus ducted. So that's a picture. It's not of my air source heat pump, but it looks exactly like the one I have. So if you're lucky enough to have central AC or heating already, a lot of times you can just put a ducted system on there. You don't have to put any more ductwork into your house. And it kind of looks like a standard AC unit you see outside of a lot of homes. I'll use my little mouse here to circle what I'm talking about. The only difference is they got to put it on stilts for the airflow. I've been seeing in my program a lot of mini split systems, especially in Minneapolis, because a lot of older homes in Minneapolis is one of the oldest housing stocks in the city, don't have central AC systems already and don't have ductwork, which could make putting in a central system really expensive. The good news is they're called mini splits. Other options here, you can look down here, you can put your little compressor unit outside, and then there's different heads in different rooms that shoot out the air there. I get a lot of questions on what a dual fuel system is. You'll hear more talk about this in Minnesota, I'm sure, because there's some policy changes coming down the line federally and in Minnesota. That's essentially adding a heat pump to an existing, this is a furnace system, and then having a smart thermostat that allows those two components to kind of talk to each other. So when you hear dual fuel, that's what that means. All those other terms on there, they all kind of relate to energy efficiency. So I kind of try to make a little guide here. So Your SEER rating is, you know, kind of comparable to what you would see with regular AC systems. That's the same kind of rating system they use. And you want to look for one that's 16 or higher. The coefficient of performance, that's a kind of a heat pump specific term that's used more when selling those. And that's just kind of looking at what's the heating efficiency at a different range of temperatures. And I'll show you an example after this slide. Single stage versus two stage, you can think of that is, does it go at one speed the entire time, or can it, put out a little bit of cooling when it's not that hot out and then ramp up to a different level when it's even hotter outside? So generally two-stage systems are going to be your more efficient systems. And then cold climate heat pumps, I won't go, you can kind of see how that all comes together there. Are heat pump systems that are designed specifically for cold weather climates. So ones that would work throughout the entire winter here in Minnesota. Here's an example I stole from my spec sheet that anyone could ask a contractor for. Looking at the coefficient of performance here. So you can see, I'll just go to this middle one here, this coefficient of performance. These are different temperatures right here. So you go to 5 degrees and you see it's 2. So what does that mean? Essentially, it means that the heat pump, for every kind of unit of energy going in, it produces 2 units of heating coming out. So that would mean it's about 200% efficient at 5 degrees. So still a lot better than a furnace, which would be cranking at 96% efficiency. So why are people talking about air source heat pumps a lot? The first primary benefit is reducing fossil fuel use. If you were at the talk with Mary Britton earlier this year, she talked a little bit about the different steps she's taken at her home. And one of them was adding a heat pump. So heat pumps, they run on electricity. So they're kind of shifting that heating load that's normally done by gas and moving some of it to electricity. So that has a carbon benefit because electricity here, in at least in the Twin Cities, is less carbon intensive than gas. Another benefit is potential cost savings. So one of the tools everyone wanted me to show from the leadership meeting, it's linked here. It's kind of this cool chart from an Minnesota Air Source Heat Pump Collaborative, where you can kind of play around, pick your different utility, what your fuel type is. Well, I guess for Austin Utilities, it's natural gas, and then what electricity rate you're on. So I'll do the most common one here. I'll do XL center point. So this would be your Minneapolis residential systems. So you can kind of compare what costs might be for kind of a conventional AC furnace system with different combinations of switch over temperatures here. So when your furnace kicks in versus when your heat pump is running. So mine is currently set at 35 degrees. So the cost is just a little bit of cost savings, but it's about equal to having a furnace AC combo right now, but just with fewer carbon emissions. And you can kind of see that reflected here by a similar number of hours you might be running your heat pump versus running your furnace. So if I switch this to 35 degrees here, this might be a little small on the shared screen. I'm not sure. Can see that your heat pump is running about 53% of the time, which means your furnace is only running 47% of the time. So that's a pretty big chunk of your carbon emissions that are getting cut from there. So this is a link to go look at that little tool if people are interested. Another consideration is, I get asked a lot, what should I set my switch point at? So this is a chart made by that same collaborative where you can scroll down to your electricity rate, which usually residential electricity rate in Minneapolis is about 13 cents. And then what the gas rate is right now, I looked at my last gas bill, it's at 115. So the switchover point, that's where you would save money, is about 40 degrees. We're not using gas right now. I imagine gas might be closer around here by the winter comes around, just because of more demand and gas supply shortages. So then you're getting into this 35-degree range. And it even has propane if any of our members are kind of out in areas that they use propane. You can kind of see that the benefit accrues a little faster than natural gas. So kind of the theme was heat pumps have been in the news a lot recently. Most recently was the Inflation Reduction Act. There's some pretty good incentives coming down for different types of heat pump technologies. And you don't only use it for AC and heating. There's also some heat pump clothes dryers and heat pump water heaters. So all kind of gas loads that can switch to electricity. I put some resources down here that were pretty cool. This is like a calculator. You can input your own, household size and income and see what the different incentives coming down from this bill that just passed are, as well as the White House's most recent explainer. Biden also invoked the Defense Production Act, with one of the focuses being to increase the domestic supply of heat pumps. So one of the challenges right now is there's so much demand for it, and there aren't as many, like manufacturing supply hasn't caught up yet. So big takeaways from this, consider a heat pump if replacing your central AC system or adding AC to your property. Those are probably the most common heat pump projects I see at my job. You can save money and reduce carbon emissions. And there are also heat pumps available for other appliances like water heaters and clothes dryers. Water heaters probably make the most sense right now, but all this is kind of coming down the line with the theme of replacing gas appliances with electric appliances, which will save carbon emissions in the long run. So I think I went a little long. Sorry, tried to go fast. But if you have any further questions about heat pumps, let me know. And sorry for keeping you like 5 minutes over.
It was a nice summary.
Yeah, thank you very much. I'm wondering, can one use a heat pump on hot water heat systems?
Yep. So there are heat pump water heaters out there.
For house heating?
Yeah, for like you said for water heating?
Yeah.
Yep.
Yeah. Okay.
Yeah.
I lived in a house where we put one in and replaced a natural gas water heater that went out. And I lived it was a basement apartment. About 50% of the square footage of the basement was an apartment, and the other half was, mechanical room with the water heater. I did notice the room got colder because it was effectively drawing heat out of the air. They're really pretty amazing. But they're now designing them with ducting, so you can actually run duct work to outside or to another source if you have an indoor space for your water heater, and you can duct the air outside, and that can be more appropriate in a living space.
Yeah, I always asked what the effect was for if it was negligible, like the heat drop, like taking heat out of your basement and then like maybe your furnace cranking up a little bit more to compensate for that. But my home wouldn't notice because I don't have a thermostat in my basement.
I have I'm not sure that we're on the same page. So I have a hot water heating in my home, like radiators.
Oh,
yeah.
Got it. You're talking like replacing a boiler system.
Yes.
Okay, sorry. No, we were not on the same page at all. So it could be designed to work with a hot or a boiler system, depending on how old it is. You know, that dual fuel system.
Yeah,
You'd probably have to put mini splits in. There are some like ground source heat pumps that heat using transfer and water, but I'm not sure
Mhm.
that's a one-for-one replacement for a boiler.
yeah, okay. All right, that makes sense. Thanks.
But if you live in Otter Tail Power Company territory, they have a lot of really good heat pump incentives because a lot of their company or their customers are on like propane or electric resistance
Oh,
heat,
sure,
and so it makes a lot of money saving
yeah,
sense for them to switch. So
yeah.
in Excel right now, you only get $450, but out in Otter Tail territory, it's like multiple thousands right now. Last time I looked.
Work for the do weatherization work for with a community action project, and for income qualified households, the state of Minnesota, our overlords is Department of Commerce.
Mhm.
They have allowed that we can recommend, we can spec a uh, cold climate air source heat pump for an all electric household at this point.
Yeah.
It's moving in. It's becoming more available even to us.
Yeah.
Huh.
And one thing I didn't cover was there are some, as Ben probably is aware, there's some state law changes coming down the pipeline to allow for like beneficial fuel switching in the utilities rebate programs. So before it wasn't really allowed, but there'll be some limited use cases. I guess we don't quite know what they are yet, but there'll be some use cases for that moving forward.